Hello everyone, so in this video we're going to be covering OCR A-Level Chemistry 3.1.1 Periodicity. So let's start with the chapter's name. What is periodicity? And why should you care about periodicity? So periodicity is basically the fancy way of saying trends that repeat in the periodic table. So if you understand this, you'll start to see patterns in elements instead of just memorizing random facts. This topic is literally the key to predicting how elements behave in bonding, reactions, and even real life applications. So let's break it down. What is periodicity? So, what does periodicity even mean? It's simple. It's just the repeating trends in physical and chemical properties as you move across the periodic table. Periodic table. You have seen the periodic table with rows and columns and wondering what does it even mean. So, it's just filled with elements and we have certain trends in the periodic table. The certain trends exist because of the changes in structure, like atomic structure, like nuclear charge, electron configuration, and shielding. So these trends occur due to repeating electronic configuration as the atomic number increases. So for example, you can look at period 3, sodium to argon. So the key facts that control these trends is the nuclear charge. So you have the nuclear charge, you have electron shielding and atomic radius. What am I talking about? The nuclear charge, electron shielding and atomic radius. So nuclear charge is nothing but the protons. More protons mean stronger attraction to the electrons. And the electron shielding is the inner electron block attraction from the nucleus. So atomic radius is the distance between the nucleus and the outer electrons. So now let's break down these trends one by one. Okay, so first of all, we have the atomic radius. Does size really matter? Yes, size matters, at least when it comes to atoms. Moving from left to right across a period, atomic radius decreases. Why? Because more proton in the nucleus means stronger attraction, pulling outer electrons closer. And same shielding means same number of electron shell. So no extra shielding to counteract the stronger pull. And then there would be tighter pull. So if there is tighter pull, which means the way smaller atom. For example, sodium. So before watching this video, you actually need to take a periodic table in your lab so that you can actually look at the trend. So in your periodic table, look at sodium. Sodium is a big boy. And then you look at chlorine. Chlorine is tiny compared to sodium, okay? So the closer electrons get to the nucleus, the harder they are to remove. And this leads us to the next trend, which is the ionization energy. So ionization energy is nothing but how hard is it to steal an electron. So ionization energy is the amount of energy required to remove 1 mole of electron from 1 mole of gaseous atoms to form 1 mole of gaseous 1 plus ions. Across a period, it increases because it gets harder to steal electrons as atomic attraction gets stronger. Why? So let's look at why. Because more protons, which we call increased nuclear charge, so strong attraction to the outer electrons. And then smaller atomic radius, so outer electrons are held more tightly. And then same shielding, so no extra inner electrons blocking the nuclear pull, no extra repulsion, so outer electrons are harder to remove. But we do have an exception because chemistry likes to be difficult, right? So the exception is for in group 2 magnesium to group 3 aluminum. So aluminum's outer electron is in 3p orbital, which is higher in energy and further from the nucleus, making it easier to remove. So aluminum's outer electron is in the 3p orbital, which is higher energy than magnesium's 3s, so easier to remove. Then is for of group 5 to group 6, that is phosphor to sulfur. So sulfur has paired electron in 3p orbital. So repulsion makes it easier to remove the electron. Think of it like this. It's easier to steal a wallet from someone with the hands full than from someone gripping it tightly with both hands, right? So when you talk about this in exam, always mention nuclear charge, shielding, atomic radius, and exception when discussing ionization energy, okay? So that you can get full marks. And the next thing is electronegativity. So electronegativity. Electronegativity is basically how badly an atom wants an electron when it's bonding. So moving across the period 3, electronegativity actually increases because more protons, stronger pull, smaller atomic radius, nucleus is closer to shared electron, same shielding, which means no interface blocking attraction. Okay, and then we have electrical conductivity across the period. Who's a good conductor? Ever wonder why metals conduct electricity and non-metals don't? It all comes to delocalized electrons. So metals, sodium, magnesium, aluminum have delocalized electron in metallic bonding and are good conductors. Except for silicon. Silicon is an exception. We can call silicon a semiconductor. It kind of conducts, kind of doesn't. And then we have non-metals. These are poor conductors. So they do not have delocalized electrons, no free moving electrons in covalent bonding, so they're poor electrons. So if you ever need to wire a house, use aluminum, not sulfur, unless you like fires. And then silicon is a metalloid and a semiconductor, so it conducts electricity only under certain conditions. So it actually shows a lot of attitude, that's why. So in exam, always link to conductivity and electron movement, okay? Then we're going to talk about the melting and boiling point. Who's the hottest? Now let's talk about which element melt and boil at the highest temperatures and why. The trend isn't smooth. It actually has some weird peaks and dips. So let's start from metals. From sodium to aluminum. High melting point and boiling point due to strong metallic bonds. Aluminum has highest. So aluminum is gonna melt very late. And then let's talk about silicon as separate. It has very high melting point and boiling point because of the giant covalent structure, so lots of strong covalent bonds. Then let's talk about the simple molecular structure that is the non-metals. There's phosphorus, sulfur, chlorine. So it has low, and do not talk about argon because it do not make bonds. So low melting and boiling point due to weak van der Waals forces. It's because it's argon. Why should I not talk about argon? Because argon has a low melting and boiling points, not because of weak van der Waals forces. It is because it's monoatomic. It only has weak van der Waals force and it's monoatomic. It does not form any bonds. Okay, so this is everything you need for the periodicity chapter. So if you want any mnemonics, you can take screenshot of the thingy of the notes so that you can actually memorize it and get full mark. For example, NASA means it's a mnemonic for first ionization energy. Then N for nuclear charge increase, A for atomic radius increase, S for shielding stays the same, and A for attraction to electron increases. So if you actually memorize these mnemonics, you're ready to write the test. So thank you very much for watching this video. Bye.